You know a lot about graphing polynomials. You even know a little bit about end behavior. We just didn't call it that before. Now we're going to formalize how we write the end behavior of a function. So let's look at the patterns first for odd functions. So when I say an odd function, I'm talking about the degree. So that's like y equals x to the first power. Well, you should know that that's linear. Y equals x is just a line that crosses at the origin and has a slope of 1. So it looks like this. Well, the awesome thing is the end behavior of this is referring to what's it doing here on the ends. And every other odd function takes on the same characteristics. So if we're talking about y equals x to the third, or y equals x to the fifth, or y equals x to the 71st, it's still going to look the same on the ends. It's just going to wiggle around more in the middle. It might be more like this and turn a whole bunch of times, but the ends of it will look identical. Okay? Notice that the slope is positive in my first line, and all of these have positive leading coefficients. So the other scenario you should be really familiar with is, so what if we had y equals negative x? Okay, so your slope is negative, so again, it's still crossing at the origin. It just drops the other way. Right? Your end behavior, though, look at how it's moving. Okay, it's rising on the left and falling on the right. Every other odd function that has a negative leading coefficient, like y equals negative x to the fifth, y equals negative x to the ninth, okay, if it has a negative leading coefficient, it's going to look the same. It may wiggle around in the middle a bunch of times, but off on the ends of it, it will rise on the left and fall on the right. Okay? So that pattern, like, you don't have to learn anything new if you just tie it to the linear functions that you already know. So now let's consider what even functions look like. Well, you should know the most basic even function, which is y equals x squared. And what does that look like? Well, you know that it's a parabola that opens upward. Okay, so what's the end behavior? Well, the end behavior of this, look at how the arms kind of go in the same direction. They're both pointing up towards the sky. Every other even function, like y equals x to the fourth, y equals x to the 10th, y equals x to the 120th, they're going to turn around a lot more, but so they'll wiggle around in the middle, could drop like this and look all kinds of funny there in the middle. But on the ends, they're both going to rise just like the one you already understand. Okay, so what controls it? Well, the fact that it's got an even exponent and a positive leading coefficient. But what's the other scenario? So if it is still even, y equals x squared, but now the coefficient's negative, our a value is negative, we always called it. What does that do? You know it opens upside down. So the end behavior is dropping on the left and the right. Okay, it's going towards negative infinity. So if I have y equals negative x to the fourth, or y equals negative 10, or I could even, just so you don't get confused here, I'm going to make that be an odd number so you don't think it's the leading coefficient. If I had y equals negative 7x to the 10th, okay, so my degree is even. That's what's controlling this. And the leading coefficient is negative. So it's going to still drop on both sides. It's going to wiggle around a whole bunch of times. But the ends of it will look exactly the same. Okay, so the highlighted part is what I'm talking about with end behavior. So let's talk about how do we write end behavior properly. Okay, so it's written like this, and you're going to write two statements. You're going to consider the left side of the graph and the right side of the graph. So this statement right here, okay, this is read as x approaches negative infinity. Okay, so it's really saying as x is moving to the left, because it's getting smaller, what's y doing? Is it going up or down? So if it looks like this and it's going up, you're going to say positive infinity because it's going up on the left. On the right side, the second statement, as x approaches, is how you read the arrow, as x approaches positive infinity, y approaches, well, in this particular parabola I just sketched, it would also approach positive infinity. So your infinity sign is just that sideways 8, it looks like. So here are the 4 cases of end behavior. I'm just going to pick 1 or 2 to quickly talk about to reinforce what I was showing you in the last slide. So let's look at this one down here in the lower left. Okay, so this is an odd function, just like a line. It's going to be like this on the ends. So the formal way to write end behavior, well, the statement here at the top is the left side, and this is the statement on the right side. How do I know that? Well, this is saying as x gets smaller, all right, as it moves towards negative infinity. That will never change, okay? That's kind of a standard thing you write. What does y do? They're calling it p of x. So as x gets smaller, p of x gets, this is saying it's going up towards positive infinity, and that's what it's doing on the left. On the right, it's dropping, okay? So the y is going to go towards negative infinity. I'm saying as x grows, so as x approaches positive infinity, as it moves to the right, p of x gets smaller. It approaches negative infinity. So again, what will you notice as you look to the one to the right here? Notice this statement right here is identical to this statement here. That's what I'm saying. As x moves to the left, it's saying. And again, these 2 statements match. It's only the y that's going to change. As x moves to the right, it would be stating. All right, so let's put this all together now with an example of how I would make you do it for me in class. So in this one, we're told to write the end behavior for the following function, y equals 3x to the 6th plus 2x to the 4th minus 7. So here's the key part I got to look at. It's in standard form. Here's my degree. The degree is 6, and that determines whether it's even or odd. So this is going to be an even function, and what's my leading coefficient? It's 3, so that's positive. Okay, so the fact that this is even means it's going to open like this or like this, just like a parabola, okay? Because the leading coefficient is positive, it's this first scenario, okay? So now, since I know it's going to look like that, it might wiggle around a couple of times, now I can talk about the end behavior of the graph. So the end behavior, again, is what's it doing over here on these edges? Well, it's going up on both sides. So how do I formally write that? I start by talking about the x. So as x moves to the left, okay, so as x approaches negative infinity, meaning it's getting smaller, comma, y does what? Y approaches, it's going up. So y approaches positive infinity. Now let's talk about the right side. Okay, so this first portion of this statement is never going to change. So as x approaches positive infinity, meaning as I'm moving to the right, what's y doing? Well, y is going up on both sides, so y approaches positive infinity. So the part I'm saying never changes is this right here. Let's do one more example here. Okay, so in this second one, it's just written in f of x form, and I notice that it's not in standard form. So the term I need to look at is right here. And what is the degree? Well, it's 5, which makes this odd. The leading coefficient is negative 8. Okay, it's not 14. So the fact that this is odd, okay, so that's like a line. It's going to be either like this or like this on the ends, okay? Which one is it? Well, the leading coefficient's negative, so think about negative slope. It's going to look like this one here. Now, in reality, it's going to wiggle around a couple of times, but on the ends, it's going to look the same. So let's talk about the end behavior now. So the first part, as x approaches, well, on the left side, x is getting smaller, okay? It's going to move, just draw my coordinate plane, as it moves to the left. So as x approaches negative infinity, what does y do? Y approaches, well, it's going up. So it approaches positive infinity. On the right side, as x approaches positive infinity, what's y doing? Y is dropping. So y approaches negative infinity. Okay? All right, you may have to kind of study the way that this notation is written. I know that that's brand new. Just notice the placements of the commas and where the arrows go. That's very important for the formal notation. Please reach out if you have any questions.